I'm also going to start recording this session, so don't worry, it will not record your faces. It'll only record mine and the slides. At least it'll record the person talking, I believe. So let me start that. Okay, great. So welcome everybody to Service-Oriented Architecture. I'm excited to have you all here. Just a couple of things. So first of all, I would ask everyone to kindly turn your web cameras on if you haven't done so already, so that I can see you and you can see each other when you are asking questions and things like that, okay? So welcome again to Service-Oriented Architecture, and this is the first week, and we're going to just talk a little bit about the class, what it's about, why we have this class, and what my expectations are of you. And we'll see a little bit about who you are as well, okay? So before we begin, this is week 1 and there will be a week 2. Now I know that the Monday is a holiday next week, but I'm planning to still have a class next week, but on Wednesday evening, all right? I will send this out on Slack later and ask if everyone's comfortable with that. The reason I want to do that is because I don't want to lose too many lectures, and I want to have some classes which are more like just workshops so we can catch up on some technical things, all right? So I don't want to lose any weeks. So I will send out a message about when week 2 will be, when the class will be on Slack later. So this is week 1. Couple more administrative things. One is, if you have taken the survey that I sent out by email already, then you should have been invited already to our Slack and Canvas sites. Mind you, if some of you did the survey just today or last night, maybe I haven't sent out your invitations yet. So what is Slack? What is Canvas? Let's take a look. So Slack is just a group chatting website where we can talk to each other. You'll notice here that it has channels, and you should be invited to this already. So there's a general channel and a random channel where we can talk about things. Every week, I will also have a channel just for that class's topic. So after today, this week's assignment will be to set up the Ruby language and the Unix environment on your computer. So we'll have a channel just to chat about that. Okay. Canvas is on the right-hand side here. So Canvas is going to be our class website where I'm going to have all the materials for this class. So for example, for those of you who've already joined the Canvas site, you'll see a link to today's Google Meet, a link to the YouTube channel where I'm live streaming now, I hope, and our syllabus and other things, all right? We have a Facebook group. Please join that if you could. That is a Facebook group where students from this class and also all the alumni of this class, students who've taken this class in the past 10 years, are also all on there. And many of them are now in industry, so it's a great place to network a little bit with your peers who've taken this class and who are now successfully in industry, all right? And also a link to the class handouts. Once again, a link to the class handouts, and some of these links are in the chat window of this Google Meet session already, okay? And also you'll find on the Canvas website all the assignments for this class. So for example, for week 1, I've already got a whole bunch of assignments up. Don't worry, some of them are just setting up stuff, some of them are tutorials, and I'll talk about those a little bit later, okay? So Canvas and Slack is how we're going to largely communicate in this class this semester outside of class, all right? And I have been sending emails so far, but I'll probably not be sending many more emails after today, all right? So please, if you haven't done the student survey, look at the chat window. I've put a link to the survey if you haven't done it yet. And once I get your survey responses, I'll check after class and I'll invite you to Slack and Canvas. All right, great. Okay, so let's get started with some stuff about this class. So this class is about service-oriented architecture, and I am Soumya. I'm a professor at the Institute of Service Science. That's my day job. My night superhero persona is I'm also a developer. I'm on GitHub, sometimes on Twitter as well. All right, so you can find out more about me at these places. I'd like to find out a little bit more about you. So I think you should find in the bottom of your screen, or in the bottom of the Google Meet, there will be a little hand icon. Looks like this, okay? And you can use that to raise your hand. And I can see who's raising their hands by looking in the list of participants for today. All right. So I'd like you to use that button to answer some questions for me. All right. So I'd like to get to know a little bit about which department you are all from. Could I ask you to raise your hand if you are from, using the raise hand button, if you are on um, if you are from the Service Sciences Institute, if you're from the Institute of Service Science, can you use the raise hand button? All right, so there's quite a number of you who are from Service Sciences. And I know some of you are first year students. A few of you might even be second year students. So thank you so much. Okay, you can lower your hands now. All right, thank you. All right, let's try to see where everyone else is from. How many of you are from computer science, from the CS departments? All right, cool. We've got some computer science students here. Great. All right, thank you so much. You can lower your hands. Great. Um, let's see, where else are students from? I believe, uh, are there some students here from the IMBA program, from the International MBA program? Could you raise your hands? One, maybe two? Is there a third? Okay, there's a couple. Okay, thank you so much. You can lower your hands now. All right. What other departments? Let's see. I believe there's a new department that just started a couple of years ago or a few years ago. It's the Institute of Information Security. Is there anybody here from the IIS departments? Yes, we have. Okay, we have a couple. Cool. Awesome. Okay, welcome. Thank you. All right, you can lower your hands. Um, where else are people from? Is anybody from an engineering program that I have not mentioned yet? Is anybody from any other engineering departments here? You can raise your hand. Yes? No? Okay. Is there anybody from any department I have not mentioned yet? You can use the raise hand to tell me if there's anybody from any department I have not mentioned yet. Or maybe you're too shy. I don't know. So, but I think the vast majority are from from the service science department, from computer sciences, from IMBA, and from IIS. Okay, so welcome everybody. Um, good to see you all here today. So let's talk a little bit about what this class is about. Okay, so if you haven't seen the syllabus yet, it should have been available online to you already, and it's also available on our Canvas website. So our syllabus is right here. Okay, so let me just open that up really quickly. And well, that's okay. So here it is. And there's a description of what this class is about, and I'll get into that more later. So I won't go over the syllabus in that much detail right now. But there is a few things of the syllabus that I want to be very clear about, okay? So one thing I mentioned on the syllabus is how much coding should you know already? This is a coding class. I know this class is offered in the management school, in the College of Technology Management, but it is a coding class, all right? And you'll see over the semester why we're teaching a coding class in a management school, because honestly, a lot of the problems we're going to try to solve today are problems about managing people, but a lot of the solutions we're going to use involves coding rather than just management theory, all right? So how much coding should you know? To take this class, you should already be comfortable in an object-oriented programming language. All right, it could be Java, it could be Python, it could be PHP, it could be something else. But you should be comfortable in one object-oriented programming language. It could be C++. You should also be comfortable with designing web applications, web pages, I mean. So you should be comfortable with HTML, CSS. I won't really teach that in class because I expect you know that, or you can go learn that quickly. And also, I'm really hoping that you're comfortable with some level of database design, that you know what entity relationship diagrams look like, you know what SQL is, all right? And if you put these three things together, some programming, website design, or interface design at least, and database design, you should be able to create a simple application by yourself. So that's kind of a minimum threshold to join this class. I'm not saying that you have to be able to design an amazing application, but you should be able to design and develop a simple application by yourself, all right? Um, because there's a lot of basic things in application development which I'm not going to cover in class. I just assume you know it. And I know some people tell me like, oh, I don't know how to do application design. I don't have much programming experience, but I still want to take this class. I'll work super, super, super hard. Unfortunately, that's probably not enough. Okay, a lot of students have said that to me in the previous years, and they haven't succeeded. You really need to have some programming experience to take this class. All right. And the reason for that is because, well, one reason for that is because your grade, so how will I be grading you? Your grade is 80% dependent on your programming contribution to your team project. So you will be doing some individual programming assignments at the beginning of the semester, and we will have team projects for the majority of the semester. We will have a big semester-long project. It's not a final project in the sense that we don't just do it in the end of the semester. We're going to work on the team project the entire semester. From maybe week 4 or 5 until week 18, you'll be doing a team project, okay? But your grade is not the same as your team's grade, all right? Your grade will be based on what have you contributed to your team project, how much code did you write for the team project. So if you have a team of 3 people and one person writes almost all the code, then that one person will probably get an A and everyone else will probably not pass the class, okay? So it's really important that you're comfortable to write code because I'm only going to look at your individual code. And yes, at the end of the semester, I'll be looking at all the code your team has written, and I will be looking at every single line of code and trying to understand what did you contribute, how much did you understand the class, okay? So your grade is really determined by your programming contribution. I know in some other classes, sometimes you can be in a good team and still get away with a really good grade. You can't do that in this class. You have to be a strong programmer to get a good grade in this class, okay? Also note that a big part of your grade, at least 20%, comes from your participation. So I expect you to be able to talk in class or to be able to ask questions online and talk on Slack. And so your participation will also be based on how much are you interacting with other people. Okay, I'm going to stop for a quick second here and see if there's any questions just on what I have said so far. Are there any questions so far? You can use your raise hand to ask a question, or you can type directly into the chat window if you like, right? So I'll take a quick pause here to drink some water and to see if anybody has any questions. Nobody? Okay. All right. So I did send out that survey asking how many of you can, what kind of applications have you made before? Here's a little histogram of your responses. So these are the responses from at least a day or two ago of all the responses I got from the survey. The vast majority of you have done front-end developments and back-end developments for web applications. And that's terrific because that's the experience that I'm really hoping that you bring when you're coming into this class, all right? Now, an interesting thing, about 5 years ago, the number of people who had strong front-end experience would be very small. It would be somewhere maybe like less than half the class. So front-end development has really picked up really big in the past several years. In fact, until this year, data science coding was the most common type of experience that students had before they came to this class. But as this is the first year where front-end development is like the main experience that students have. And And that really reflects the rise of JavaScript and the rise of front-end developments, okay? So when I talk about web development, I'm really talking about front-end and back-end developments. And I'm glad to see that most students already have this experience because this is kind of a prerequisite for this class. Some of you have mobile development experience and desktop application experience. That's also great. That'll also help you a lot in doing this class, okay? Um, if your only experience is writing data science or machine learning code, it's not enough for this class, all right? So I just want to be very clear about that. If your only experience is writing some Python scripts for machine learning or data science or some R scripts, you are not qualified to really take this class, all right? So you should have some level of familiarity with application development. Even if you haven't done it in the past few years, that's fine, as long as you've done it before some time, right? Great. By the way, if you have any questions at any time, just use the raise hand button and I'll take a note of you. All right, cool. So what are we talking about this class? So what is SOA about now that I've tried to scare everyone away. So if you're still here, what are we doing in this class? All right. I think some of you already have a strong sense of what this class is about because in your survey responses, I got some really nice answers about why people are taking this class. So first of all, this class is all about creating information services or IT services, all right? An example of that would be something like, I'm going to use an American example here, like Airbnb, okay? It's an example of a successful online service. Um, it was much more powerful before COVID, but it's actually picking up again. So Airbnb is a website, and I think some of you are familiar with it, where you can go and book places to stay when you're on vacation or wherever you are going. So for example, I can pick in Shinju City some apartments that I can rent and I can see the prices of them, all right? And usually these are very short-term rentals, like just like 1 day, 2 days, or a week, though it's possible to rent something for a month or longer. And Airbnb is an example of a fairly successful online service, and it's got like a website interface and also a mobile interface to it, okay? Perhaps an example of a service that has done really well during COVID. Can anyone give me any examples? Like in the chat window, can you type the name of any online service that you think has done really well during the COVID pandemic? Anybody? I'm going to wait for a couple of answers. Go ahead and type, okay? All right, cool. Food Panda and Uber Eat. Yeah, Uber Eats. Yeah, exactly. So these delivery services have done they've really picked up during the pandemic. Let's see what else people are saying. Spotify. Yeah, absolutely. You're stuck home all the time. You're probably listening to a lot of music. Or if you're like me, the only time I get out nowadays is to go do some exercise outside, and I might be listening to music. All right, so more Uber Eats. Netflix. That's a really yeah, that's a really good example. Netflix has done, I think, super well during the pandemic. I haven't seen the numbers, but I'd like to see it because, again, we're stuck at home a lot. A lot of entertainment is not going to be just from TV. All right. Let's see what else. More Uber Eats. Uber taxis. I don't know how well they've done. I think they may have suffered a little bit because people really don't want to get into a car with somebody else right now. Um, Google Maps. Okay, I like that answer. Google Maps, perhaps. All right, especially if you're getting around by yourself now and trying to avoid buses and things. Reddit, yeah, sure, I'm on Reddit. All right, so yeah, I think a lot of people are on online communities and things like that. Shopee, yeah, for sure. Online purchasing like Shopee and PC Home are probably making a lot of money during the pandemic because people are just trying not to go to stores if they don't have to. All right, Google Meet, Discord, absolutely. Outside of Taiwan, what's the big one that people are using instead of Google Meet? I'll wait for somebody to type that. Um, I want to see what else people are saying. YouTube. Yeah, sure. Zoom. Yeah, absolutely. Zoom is like huge outside of Taiwan, and it's completely taken over the space that Skype once had. I'm seeing what else people are tapping. Bolt Company, a mobility company that offers vehicles for hire. Oh, micromobility, car sharing, food delivery. Yeah, absolutely. All of these things. I haven't heard of Bolt before. Is that a Taiwanese company, Billy? Anyway, or where is that? Okay. Coursera, yeah, all these online courses, online services are doing super great business right now. I noticed in India, for example, among startups, and I'm just familiar with the Indian markets, I'm just mentioning that. Um, ed tech or educational IT services are now the third largest type of startups coming up in India right now. So it tells you a lot of people are at home. A lot of people are thinking of switching jobs these days as well. So they're trying to re-educate themselves on new things. Yeah, sure. Things like Figma and perhaps for like development and things are doing really well. Okay, great. Oh, Bolt's an Estonian company. Cool. Okay, I got to read about that later. Okay, so thank you. So there's a lot of examples of really good service providers who are doing really well. They grew really fast, they scaled really well, they're easy to use, they're useful, and many of these online services are also considered some of the best places to work. All right, I think in fact, Airbnb, the example I'm using, right before the pandemic at least, it was rated like one of the top 5 places to work in America at that time. All right, so great. So a lot of services are doing well, but at the same time, there's a lot of services that are maybe not as competitive as they could be, all right, are not surviving very well. And before I get to the big examples, there are some examples that we can probably think of that we used to use before the pandemic that are not doing so well right now. My classic example might be something like Skype. Skype was like, it was a verb, like that was a dominant way in which people talked to each other, had business meetings and things like that before the pandemic. But then the pandemic happened, and Zoom and to a lesser part, Google Meet kind of completely took over. What happened to Skype? Like, how come they couldn't change? Why didn't they change what they're doing? So there's a lot of services that were not actually able to adapt and change with time. All right. And I would like to think that all of you are going to be successful service providers one day, and you'll be creating amazing services. And but at the same time, we have to understand why some services are able to like grow quickly and able to change quickly and offer great services, and others struggle to do the same thing. All right. So this class is really about that. How can you avoid some of the problems that companies run into and they're unable to change? Now, I give you a reading for today. The reading was about a healthcare website in the United States, I think. It was called healthcare.gov. This was several years ago under the Obama administration. And it was a really public example of an online service that completely failed in the beginning, at least. I think it's doing okay now, but the government spent a lot of money in the U.S. to create this healthcare portal for people to come to get like insurance and other healthcare information, and it was a spectacular failure. And it's not the only story. In fact, it's very easy to find a lot of stories about big government systems that failed. Here's two more stories in the bottom from this time from the UK, from the United Kingdom. This was another healthcare service, the NHS IT system. They spent over $10 billion trying to build an IT system for healthcare, and they failed, and they almost had to abandon it. All right, and there are other services that face the same problem. Um, and I asked you all to take a read to read at least a story about the healthcare website. Does anybody remember what were some of the reasons why this healthcare portal in the US with billions of dollars of money, why did they fail to make a successful service in the beginning? Does anybody remember what the reading said? Again, I'll wait for a couple of answers. While I'm waiting, I'll let you know that every so often I'll be giving readings, and I really expect you to read them. All right. So let's go with Billy. Could you unmute yourself and speak? Excellent. Yeah, absolutely. Thank you, Billy. So one of the reasons that was mentioned in the reading why this healthcare portal with billions of dollars failed was actually surprisingly because there was too many programmers. Not because there wasn't enough programmers. There were too many programmers, and coordinating all the work between all of them was really difficult. All right. From Chuan, I'm getting a couple of answers here in the chat window. So one is the Big Bang release, right? So they tried to make a system and then just release it for millions of people one day. And that turns out to be a really bad idea. And it's one of the biggest reasons why a lot of these government websites fail is because they open and they say, okay, now millions of people can use this. And as soon as millions of people come, two things happen. One is the website often crashes because it cannot handle millions of people. And the second thing is people started using the system and realized this is not what they wanted. And they have a lot of complaints about it. Okay. So releasing something really big and the quote that Chuan gave is that the most danger for all failure points is this big bang approach. All right. Let's see some other answers people are saying. Uh, Developing specifications correctly. All right. So this is a really interesting problem and question. You're trying to make an IT service. How do you specify what it should do? Right? Like, how do you do that? Do you just like give a verbal description to programmers and say, I want a website that does, like, do you give a long verbal description? Do you give, do you write down a very complicated specification in English? Like, how do you specify the behavior of an IT system? And one of the big problems with making an IT service, especially for somebody else, is that the people using it will say, this is not what I wanted. This is not what I expected. This is not what I asked for. And that's very surprising for many programmers because they feel, I talked to you, you told me what you wanted, I made it, but it's like not, it's completely not what they wanted. So it seems to be that it's not enough just to ask somebody what they want. How do you get them to specify very exactly what is the experience they're looking for? So this will be one of the questions we'll be tackling this semester as well. Okay. Um, what else? Over budget and didn't meet expectations. Sure, it's over budget, but they had billions of dollars. How did they go over budget? Didn't meet expectations, what I was just talking about. You make something, but the customer says, that's not what I asked for. There's always a big communication gap between what your customers want and what you're making. So how do you get past that? All right. And some other answers here from Nian Hong is large projects have excessive loads and incorrect data recording. Yeah, so certainly you're going to have a lot of people coming on, and storing data accurately is going to be a big problem. And we'll talk about why that is throughout the semester. The last answer I see here from Shinli is too much bureaucracy. Yeah, there's too many people involved in the project, and not just programmers. There's a lot of managers and a lot of people involved in this, and it's very hard to get them all to work together. Okay, thank you so much for all these answers. And if you're not familiar with, with the failure of services, I think one thing you'll find from this reading is that IT services fail more often than they succeed. In fact, this is my notes from the same reading, that healthcare.gov reading. And one of the things they mentioned is of the 3,500 projects that they studied from in a 10-year period, and these were large projects of at least $10 million in hiring costs, okay? So of 3,000 projects they studied, only 6% were actually successful. That's crazy. Like 94% of services with like millions of dollars to spend fail. That's incredible. There's something completely broken about the way we are designing software these days. Okay, not just these days, forever. All right. So they break that down a little bit. They say 52%, half of the projects they studied were challenged, meaning they were over budget, behind schedule, that didn't meet users' expectations. Another 40% were complete failures. They were abandoned after millions or maybe even billions of dollars were spent on them. All right. And okay, so there are multiple issues. So what goes wrong? And my notes are very similar to yours. Big bang release is a big problem. All right. So this semester we're not going to do a big bang release. We're not going to wait for the end of the semester to see your application for the first time. Okay. Um, One problem that nobody mentioned here, and I will argue this is probably the most pervasive problem, is that there are too many changes along the way. What happens is you get an initial description of what you want, what you're supposed to make, And as you are developing it, your customer or your users or your managers start changing their mind every week. They say, oh no, we don't want this, we want a little bit more of that. Oh no, no, that doesn't work, we want this. Like, and as things keep changing, your system cannot keep changing with people's minds. And this is probably the biggest problem we're going to try to focus on in this semester, which is that change to your system is very complicated. And for people, especially some managers or users who do not do developments, they feel that, hey, why don't you just change some feature X to do something else? And they don't realize that changing something can take weeks, months to do on a system. And many non-developers have this notion, well, you can just do that today, right? And they don't realize it can take a long time to do, and it gets very complicated. And I'll talk about that in a little bit more detail in a moment. All right. So I also noted that developing specifications is difficult, and having many people work together is very difficult. All right. So if you've not encountered these kind of stories about IT service failures, welcome to the real world. A lot of services fail, and you should be aware of the problems that they are facing. All right. Now, we are not in this class trying to develop a billion-dollar government system. That's not what we're doing. Okay. In fact, we're going to be developing code more like a startup. All right. So what about startups? Can I just kind of get your opinion on this? Do you think some of the problems that you're reading in this article could apply to startups as well, or maybe medium enterprises like small companies or medium companies? Or is this just problems that big companies have? What do you think? You can raise your hand or you can type an answer. I'm happy to see either. Anybody? Oh, okay, yeah, Billy, go ahead, please. Okay, thank you so much, Billy. So you're saying this is really a problem of big companies. Small companies may not have to worry about it. I'm reading some of the other answers in the chat window, and Edgar says, well, there's a few startups that have been working for 4 years and they already have 2 or 3 or 4 projects successfully, right? I'm getting another answer here saying too many changes may be a common problem because you want to meet every potential customer's requirements, but it's impossible. Yes. So let's talk a little bit about small companies, all right? And I want to talk about small companies because many of you might enter startups after you kind of leave school, or at some point in your life, you may start a startup or start a project in a company. And by the way, when I say startup, it doesn't have to be just a few people with a new company. You could also be creating a new project in a big company. And in that sense, you're also a kind of startup just within a company. All right. So, what happens when you start making a project? So, Billy was telling me that, well, small companies maybe have the luxury of doing things step by step, all right, and doing things systematically. In my experience, it's not quite that way. And let's talk about this, all right? So when you're creating a new service, and you might be a startup or you might be a small team inside a big company and you're making a new project for the first time, all right? There's a couple of big challenges upon you. One is typically the people for whom you're trying to make this, it might be your managers, it might be your investors, it might be your users. Usually, they don't want to wait 6 months to see something. Like they want to see something tomorrow. They want to see something yesterday. There's a lot of pressure on new startups or new services, even in large companies, to show results right away, to have something to show this month or next month. And so oftentimes you don't have the luxury to say, hey, let's design this really nicely. Let's think about what we're making very carefully. You're often rushed to make something very quickly. Okay. And if you end up making something that people don't want, well, we never hear about you. You just kind of disappear. The problems begin when you become successful, right? Like you're a new service and you become successful, and then suddenly you find yourself like, hey, we have a product that people want to use. But, oops, excuse me. when you have a product that a lot of people want to use, you have some other problems, all right? One is, in the beginning, you made some really simple features and you kind of put them together and it looked really nice, it worked really well, and you're very confident. Every time I talk to a startup that's only, let's say, 1 year old, and I work with a lot of startups, so whenever I talk to a startup that's only about 1 year old, they're very confident. They tell me like, oh, we have the best programmers, we're doing so well, we're able to make things so quickly. They're in a kind of honeymoon phase where everything is looking really perfect. But then, as one of the responses said, too many changes, customers start asking for a lot of things, and pretty soon these companies are trying to put things together that were not made to go together. And what began as a very simple feature or a very simple service starts getting very complicated, and it's very hard to put all these pieces together. All right. Um, and I'm getting this answer here also that I think for a startup, that too many changes issue is also a problem. All right, that services, they have this innovation. They need to show that they're innovating. All right. Um, oops. Sorry, my connection suddenly. Sorry, my connection suddenly slipped. Can you hear me clearly? Can everyone hear me okay? Yes? Okay. Okay, thank you. I'm going to go back to sharing my screen, okay? Um, and hopefully you'll see my screen sharing in a moment. Okay, it's going to take a few seconds. All right, thank you so much. Okay, sorry about that interruption, okay? I have to be careful what I click on my computer. All right. So, all right, so things start changing. Moreover, you start with having a really simple team, just like a few developers, right? And again, when I talk to companies with just 3 or 4 developers, they're really confident. They tell me like, everyone works so well. We're like a little family. That's great. But then as you become successful, you start having a lot more people. All right. So it's true that startups seem to have this notion that they've escaped the problem with big companies. But as you start becoming successful and you get a lot more people, it becomes very hard to manage them. All right. I'll give you a couple of examples. So I was dealing with one company. It's a big company, but in Taiwan they have a medium-sized operation. Maybe they had like about 20 developers or 15 developers. Okay. And one thing I found is every time they had a new project, they would hire new people. So every time they got a new customer who needed a new thing, nobody in the company had time to work on the new thing. So they just hired like 3 more developers to work on the new product. So pretty soon they're working on 3 or 4 products and they keep hiring more and more people. And it becomes very hard to organize all these people and to make sure that they are all kind of collaborating with each other. And last of all, when you're a small company, it's easy to say, like, hey, we have a very clean architecture, everything is designed really well. But when you're under a lot of pressure to innovate very quickly, to add a lot of new features very quickly, your simple architecture, your simple system becomes, and this is like the industry word, it becomes what we call a spaghetti architecture. Do you know what spaghetti is? It's like pasta, like mian, all right? So why do we call it spaghetti architecture? Because everything is connected to everything else. Like you have a system with a database and everyone's talking to the same database with the same resources, the same everything. And what happens pretty quickly is that we call it a spaghetti architecture because if you have like a bowl of mian of noodles and you pick up one noodle, what happens? A lot of the other noodles come with it, right? And this is the same thing. What happens to a lot of companies is they start with a simple architecture, but as they add more things, they find that as they try to change one thing in their system, other things start breaking quickly. All right. So the problems we were talking about with large enterprises are not, in my opinion, are not just a problem of large enterprises. They're a problem of every successful enterprise. If you have a successful startup, you will end up in the same problem as what you were reading about with the healthcare portal. All right. It may not happen in your first year or your second year, but usually within the first few years, companies run into these kind of problems. All right. And what happens when they run into this problem? All right. Well, before we get into what happens, let me just kind of give you a few like of the stories of what happens. All right. So the theme of this class is change. The enemy of all your code that you're writing is change, that you have to keep changing it, all right? And when you keep changing code, it becomes harder and harder to change. It becomes more interconnected. So let's talk about some of the things that that happens. One is, as we talked before, people keep demanding new features. It could be users, it could be managers. All right. And when people start asking you for new features, they don't want it next year. They want it next month or next week or tomorrow, even better. And what happens is you just start adding code quickly without thinking very much about how does it impact the whole system, because you're just under pressure to deliver next month. Nobody, your manager or your customers, they don't care about the architecture of your system. So you start adding more and more code, and you start finding that your new code starts breaking your old code. All right. And you start spending more time debugging the old code than writing new code over time. All right. So, or another thing that can happen is you finish a feature and you put it in production, but you find that, my God, the feature worked perfectly on my computer, but it doesn't work on the production computers, on the production servers. Like it worked on my laptop, but it doesn't work on our servers. And even after you deploy a feature, you start spending time debugging it on the servers in real time. And that's kind of some of the stories you read about the healthcare portal, is that they put things online and people started finding problems right away. Okay. So when you put things in production, you're not done. In fact, the major headaches begin where you find yourself debugging your code all the time. All right. And while you're doing all this, the environment you're working in changes. For example, let's say you're developing mobile applications. Apple will keep changing their operating system every year, right? And you want to spend time making new features and new apps, but you find yourself constantly spending time updating your code and trying to match the new operating system and things like that. All right. And what's even worse, and I've got a really good story about this, is sometimes in a company, and especially in a startup, a programmer who knows a lot leaves the company, right? Like, so I was talking to a company in Taiwan once. It was a startup, a very successful startup, where the entire backend, the API of the entire application was written by one programmer, and the programmer just left the company one day. All right. What do they do now? Well, it's easy to think, oh, no problem, they left. Let's read their code and understand what they did. But the company told me quite honestly, we don't understand his code. It's too complicated. And they couldn't find anybody who could understand all these thousands of lines that this person had written. So what did they do? They took the next 5 months to rewrite the API from scratch. They just hired a new programmer and they said, can you just rewrite the API? It'll be easier than trying to understand what the last person did. All right. So these are the kind of changes that face companies. Sometimes it's your users or managers who want new features. Sometimes a lot of the time you'll find bugs in features you've developed. Sometimes you'll find like the environment you're operating in, it might be the operating system or some other APIs you're using have changed. So you need to change your code. And the people working on your system change, right? And what do you do when they change? Well, unfortunately, in a lot of companies I talk to, they just rewrite that person's code from scratch because they cannot understand what that person wrote, right? So we may have an imagination that, especially with startups, that they can innovate all day long. But after 1 or 2 years, most companies find that they're not innovating. Instead, they're spending time debugging, updating, rewriting code, and they're falling behind the competition pretty quickly. All right. I noticed a couple message on the chat, so let me go look at the chat window really quickly. Edgar, I don't understand what you mean by same mistake again. Could you expand on that? Or even better, just unmute yourself and tell us. Right. Yeah. Yeah. Exactly. So this is a problem. I don't want to say which company this was. It's everyone knows this company, but I won't say which one it was. But I will say that they did one smart thing, and I'm being a little not humble here. The new person they hired actually came and took the SOA class while he was on the job. Like he literally came to my class and said, "I'm not in school anymore, but I want to sit in your class because I heard like you're talking about exactly the problems we're having." So literally their new developer sat in my class and was writing the API week by week as we were doing our class. So it was a very interesting experience for me to kind of like interact with that company and learn about this problem. All right. So ultimately, this is the picture, this is the unfortunate picture of every startup or new service in a big company that I come across. Okay. Version 1 of their software is a big design and the company seems really innovative and everyone's really amazed by them. Or maybe it's some developers in a big company and everyone's amazed by the first product they ship. They say, my God, you guys are so cool. You made an amazing product. For example, I go to startups and I talk to managers, and if it's a very young startup, they'll tell me, our developer is amazing. You should see our first product. We just launched it. It's amazing. They are in this honeymoon phase where they just released their first product. Okay. Now, unfortunately, or maybe fortunately for the class, most of you, not all of you, most of you who are students and who have not had a work experience, this is your experience with writing code, version 1.0. Because you've done class projects, or maybe you've done a product for your research lab or your school, and you were involved in making the first version of the product. And you have a really amazing imagination about like, wow, what an amazing thing we made. What many people don't realize is updating that system to add another feature is going to take time, and that new feature and your new, what you add over time will not be as big as the first thing you released. All right. And then as you start making more updates, it'll start taking longer and longer time because your code begins to look more and more like this. All right. And every successive feature you make takes longer and it breaks more things that you did before. And what happens is over time, even though everyone thinks you're so innovative, the fact is within your startup or your small unit in the company, your innovation is getting slower and slower. Then the third release you have is a very even smaller and it's taking even longer. And after a while, it seems like you're just not doing anything new. And people start asking, hey, what happened to these people? They were so cool, but now it seems like they're not changing anymore. Skype, right? That's kind of the story of Skype here. They were like the verb of how to talk to people on the internet. We would Skype each other. And then the pandemic happened, and it seems like they couldn't change anything. Like they didn't adapt with it. There's hardly anything new with it. And like companies like Zoom and Google Meet came and just took it over. What happened to these companies? Like, why could they not change? Like, they know how to make a great product. Why didn't they just make it better? And the story you'll see in development is often very much like this. You start off with a great idea and you're very optimistic, but over time it becomes harder and harder to change your features. Your code gets more complicated. You've got too many people involved. All the problems you were reading about the healthcare portal, about a big bank start, software development, becomes true of even small companies over time. And that's why you see a lot of small companies, they innovate really quickly, but then after a few years, they get replaced by other small companies. All right. And we'll talk more about that in the coming weeks. So here's my question to you. What can we do to avoid this happening to us? Okay. And I'll ask these two questions. In the beginning, when you are making a new product, what can you do in the beginning to make sure your product doesn't become like this later, where over time it becomes really impossible to change it and very hard to maintain? What can you do in the beginning to avoid this situation? Does anybody have any suggestions that you'd like to give me? Like you have a new startup or you're making a new product in a big company and you don't want to end up in this situation. So what can you do in the very beginning to make sure that you can always stay innovating? Any suggestions that you have? I'm willing to hear any crazy ideas that you have. Yes, there's a hand raised. Please go ahead. Fantastic. So don't turn your mic off yet. So you said write tests, and you said one more thing. Can you say that again? Write tests and okay. Okay, thank you so much. Fantastic. So Stephen said, why don't we get people to write tests in the beginning? And this is a really good idea, by the way. This is a great idea, and we'll talk about why tests are so incredibly important in not quite yet, but in after a few weeks. Okay, because once you have tests, you have a couple of things. In fact, tests allow you to check if the behavior you're expecting of your application is breaking. All right. And if you don't have tests, you don't know if you've broken a feature that you did 6 months ago. All right. So that's one thing that tests give you, automated tests. The second thing that tests give you, and we'll really talk about this in a big way in this class, tests become a written contract about what your application should be doing. All right. It becomes one of the few pieces of written description of what your application's behavior should be. And we'll talk about how to kind of do that in powerful ways a little bit later, even today, maybe. All right. Okay. So thank you, Stephen, for that very much. What am I doing here? 1 second. Couple of other answers coming in. Try to modularize the features and components so that they have less dependencies as possible. Fantastic. So the response we're getting here is to say, before you kind of end up looking like this, start by making a system that has very clean components which are independent of each other that you can change independently. Try not to end up in a place where everything is connected to everything else, because when everything is connected to everything else, you change one thing and you break all the other things. So for example, in this very ugly picture here, if I was to change one of these systems, I don't know which one I'm going to change yet, but let's say I'm going to change this message queue, and like maybe I'm going to go from one provider to another provider. Everyone who's using this message queue, and I cannot see from the picture, but there may be 5 services using this message queue, they're all going to break, right? If I replace that message queue. How can I ensure that I have I have only one way to talk to that message queue, and that I can just change one thing instead of 5 things. All right. So if everything is connected to everything else in this picture, you change one thing, you replace one thing, you delete one thing, you'll break everything else. So you want to avoid that by making things separated from each other. How do you do that? We'll talk about it in this class. Tian, so we have an answer here about clear architecture design before starting to write the code. I agree with this answer. So Tony says, make a clean architecture. And I'll warn you one thing about this, Tony, which is you can create a clean architecture, but as new pressure comes on you, like, hey, add a new feature, it's easy to end up in a very messy situation. So, oh, jeez, again. Sorry, I keep doing this. I keep breaking the system. So I hope I'm back here clearly again. Let me try to share my screen again. All right. All right. So the problem with trying to make clear architecture is it's actually quite easy to make a really clean architecture, but then oh, excuse me, my screen is sharing now. Okay, great. So it's easy to make a clean architecture, but what happens is that as new pressures come onto you to add new features, you don't have time to maintain this architecture. You don't have time to sit down and draw a new architecture for the new feature. All right. So one of the things we'll talk about today is, can we have a systematic way of adding new things so that when something new has to be added, we don't have to make everyone meet and draw a new architecture. We all know that there's a systematic way to add new things without ending up looking like this. Okay. All right. And I think I had one more response, and I'm going to try to take a look at that. Oh, I'm so sorry. Whoever wrote the last response, I lost it now because I left the call. So there was one more thing after clear architecture. If whoever typed that, if you could type that for me again or copy paste that again, I'll be very happy. Here we go. Thank you. It was about build the architecture, easy to add features, and those who write code should write great documentation. So let me talk about both these things. You're absolutely right. So we'll spend the whole semester talking about how do we have practices to add new features in a clean way? So we'll have a discipline about how to do that. All right. So definitely that's a great idea, and we'll spend the whole semester talking about that. The next part is whoever writes code should add great documentation. Now, I'll talk about documentation a little bit this semester, because there's a lot of controversy about documentation. Like when you're in school, professors always teach you write a lot of documentation. But there's another side to this debate about documentation. There's another side that says if you write really good code and really clean code, you shouldn't need documentation. Like your code should be as easy to read as your documentation. So there's two kind of schools of thought, two philosophies. One says write a lot of documentation, but it's very difficult to do because programmers don't like to write documentation. All right, and it's very hard to document things. It's a different skill than programming actually. And there's another school that says your code should be your documentation. I should be able to read your code as if it is a description of what you're doing. In this class, I think documentation is a good idea, but I'm going to be shifting more to the side, to the philosophy that says, can our code look like documentation? Can we write code that is so clear that it doesn't need documentation? It's self-documenting. So I don't know if that's possible, but let's try it. And I'll lean towards this side where try to write great code that doesn't need documentation. But if you write code that isn't clear, please write documentation. Okay. So we'll talk about documenting and how to write clean code and what it means about documentation a lot this semester. Okay, great. Let's move on. Okay. I talked about this slide and I talked about like how to avoid this. So we talked about some things we can do in the beginning to make sure that our system can keep innovating. And our class will really talk about this, and you'll make a system from the beginning so you have time to practice this, okay? But unfortunately for many of you, or maybe fortunately for many of you, when you leave school, most of you are not going to make a new product. You are going to join a company that's at this stage already. It's got a product that it cannot change anymore very easily. What should we do if we are joining a company or we have a product and after many years we find it's too hard to change this product? It's too hard to change, to write, to add new features. It's too hard to maintain. What should you do then? Any suggestions? Like what should we do later if our system is too hard to change? I'd like to hear some suggestions or some comments. Like if you join a company tomorrow and you find, oh my God, this system is like millions of lines of code and who knows how it works. The programmers who wrote it aren't even here. They didn't document it. They don't have tests. Like, I don't know, they could be in a very crazy state. All right. So if you join a company and on day one, the company's product already looks like this spaghetti architecture, what should you do if this is what you already have? All right. Any suggestions? I'd love to hear if you can raise your hand or write a comment. What do you think we should do if we already are in a place, if you're already beginning with spaghetti architecture? Any suggestions? Don't say quit, okay? Something other than quit the company. Come on, I'd love to hear some answers. Because, from almost all of you, this is the situation you're going to end up in. You're going to get out of school, you're going to learn all these beautiful ways to make things, then you're going to join a company where nobody does those beautiful things. What do you do? Do you say, oh, my life sucks? What should you do? Any suggestions? I'm willing to hear crazy ideas also. In fact, don't give me a good idea, give me a stupid idea. I want to hear some stupid ideas. Okay, great. Maybe it's time to rebuild everything. All right. Any other suggestions? Let me go with this. Maybe it's time to rebuild everything. Just rewrite the whole system. All right. Can I take a vote? I mean, use the hands up button. How many of you think if you're in a company and you have this crazy software, raise your hand if you think a good idea is to just rebuild everything cleanly. I'll raise my hand too. All right. Okay. All right. Thank you. So several of you, okay, you can lower your hands now. So several of you agree that you can just rebuild everything. I'll tell you something honestly, that's exactly what a lot of companies do. They just rebuild everything. That's not an unusual solution, that's the usual solution. Most companies, when they're faced with software they cannot change, they just rewrite it from scratch. Okay? Let's see some other suggestions. Rebuild a small part of services as an example, share with the teammates and ask them to do it. That's a great idea. Rebuild a small part of it. Somebody else, I think Jing Han Huang has written, refactor the code architecture. This is the same idea as rebuild a small part of the service, I think. All right. Um, this is another solution called refactoring, and we'll talk about refactoring around week 4 or something like that. Okay, we'll talk about it. So this is another solution called refactoring, which is don't change everything, just take a small part and try to isolate it and try to make it clean. And then hopefully this will affect other parts. Okay, that's another great solution. Unfortunately, most companies don't know how to do this, or they think it's too dangerous, or they're not willing to do this. But we'll talk about this in the coming weeks. Some other solutions: find the initial creator and understand the history. That would be amazing. It'd be lovely to do. So this is a great suggestion. Find the person who wrote the code and ask them, what did you do? But there's a couple of problems. First of all, it may not be one person. It may be like 100 people. And they may be all in 100 places right now. So it's very hard to find them. The second thing is this. I dare you to find some code that you wrote 1 year ago. Try to read it. I'll bet you cannot read your own code from 1 year ago. You can't ask somebody, hey, what did you do 5 years ago? Nobody remembers, okay? Sometimes I'm looking at code I wrote 6 months ago or 1 year ago, and I think to myself, my God, this is so clever. I didn't know I was so clever back then, So we are too clever for our own good. So unfortunately, that's a very difficult thing to do. Some other solutions, maybe just turn to outsourcing. Find another company and ask them to rewrite it. Yeah, sure. A lot of companies do that. Okay. Um, draw the spaghetti out. Yeah, you could try to draw out the plan and try to fix it slowly, possibly, but it's very difficult. Get reset. I love that. Okay. Try to make new features more beautifully from now on. Okay, that's a good idea. So the old services sucked, but what about the new features we're making? Can we make them cleanly? It could be difficult, but we'll try to talk about that this semester. Find the core code and reorganize the functions to a good architecture. Okay, so again, there's two philosophies. Some of you say just rebuild everything, either yourself or outsource it. And some of you say just try to start with something small or start with something new. We'll talk about some of the debates about this, and we'll try to see what some of the most famous programmers in the world have to say about this in the coming weeks. Okay, so we'll read some of the debates about what to do when you have spaghetti architecture, because all of you will start your careers with spaghetti architecture. All right, so we have to have a plan for what to do when we see it. Okay, great. So thank you for all these great ideas and for what we should do. Okay, and in the beginning and later on, and we'll spend the whole semester talking about these things. This is the challenge of this class. This is what the class is about. All right. If I could draw it in a picture, it would look like this. So spaghetti architecture. Imagine you have to like this is an electrical system. And imagine, all right, and you can see the wires are everywhere. Everything is crazy. Imagine something isn't working in this electrical system and you have to change some wires. Would you dare to touch this system? I would be scared. Like, would you know what to touch in this system? Like, you change one thing, you don't know what you're going to break, right? And most code looks like this. Most real world code looks like this, especially if it was a successful product and they had to develop very quickly, it begins to look like this. And nobody wants to touch this. all right? What we want to do this semester is to write code that looks like this, all right? It's super beautiful, it's clean. If you have to change something, you know exactly what to touch, you know exactly where it goes, all right? These are both electrical systems. So we will learn this semester, we're not doing electrical systems, we're writing code, but we don't want our code to look like this. We want our code to look like this, all right? And that's what this semester's class is all about. And we're going to do it in a few steps. We'll talk about some of the dangers of spaghetti architecture and what it looks like. And we'll start by a simple thing called layered architecture. We will see when you have code on one computer, just one small application, how do you separate your code into multiple modules, as somebody said in the comments, to make it very easy to organize and very clear what it does. And then when you have one service that looks like this, how can you add more and more services so they talk very cleanly with each other? All right. So we'll talk about the transition, how to make a single system very cleanly with a layered architecture. And then we'll talk about how do you make many services talk to each other in a clean way with a larger system architecture. So that'll be kind of the what we're going to do this semester. All right. Cool. So I want to take a little break. All right. So we've talked about what we'll do, and I want to come back and talk a little bit about how we're going to do it and some of the details of this class. But this is the motivation of the class. Okay. So I'm going to take a little break. If you have any questions, feel free to write them in the chat window. But it's 10:07 right now. Let's get back here at 10:15. So let's take about an 8-minute break. Go use the restroom, go get some water, get some tea, some coffee, something to eat. Okay, and at 10:15, I'm going to start talking here again. So, all right. And in the meantime, I'm going to stop the recording, and I ask all of you to please turn your webcam off during the break because we don't want to see where you're going during the break, okay? All right, so thank you. We'll be back here at 10:15.